There is a place along the Susquehanna River, 2 miles north of Harrisburg, Pennsylvania, where a structure of such quiet permanence stands that it is easy to mistake it for something ancient, something carved by a civilization that knew the river long before the railroad age. 48 stone arches, each spanning 70 feet, stretch from the borough of Rockville on the eastern bank to Marysville on the west. At 3,820 feet, the Rockville Bridge is the longest stone masonry arch railroad viaduct ever built. It is a record that has stood for more than a century, and no one has yet thought to challenge it. But the bridge that stands there today was not the first to cross that stretch of water. Long before a single stone was quarried, the Pennsylvania Railroad planted a more modest seed at this site. On September 1st, 1849, a one-track wooden truss bridge opened across the Susquehanna, a practical structure for a practical age, sufficient for the traffic of its time. The Northern Central Railway eventually came to rely on it as well, abandoning its own Marysville Bridge in favor of this crossing. The two railroads shared the span in an arrangement that speaks to the pragmatism of early American railroading, competing enterprises recognizing, at least in this instance, the value of a common resource. Wooden bridges, however, are not built for forever. By 1807, the demands of American railroading had grown beyond what timber could answer. The wooden truss gave way to a double-track iron bridge, a structure that reflected, in both its material and its added capacity, an industry that was expanding faster than anyone had imagined possible. The addition of a second track was itself a statement. The Pennsylvania Railroad was not building for today. It was building for the traffic it intended to generate. Yet iron, too, proved insufficient. By the close of the 19th century, the Pennsylvania Railroad, then among the most powerful transportation enterprises in the world, understood that the future demanded something more permanent. Locomotives were growing heavier, freight volumes were climbing. The iron bridge that had seemed so modern in 1807 was already straining under the weight of a new century's ambitions. In April of 1900, construction began on a third crossing, one that would be built not in wood or iron, but in stone. The engineering logic behind that choice was as sound as the material itself. Stone masonry arches transfer load through compression, a structural principle as old as the Roman aqueducts and as reliable as anything in the engineer's repertoire. Where iron corrodes and wood decays, properly laid stone simply endures. The 48 arches of the Rockville Bridge, each one a 70-foot span carried on piers rising from the bed of the Susquehanna, were designed to carry loads that no one in 1900 could fully anticipate. They were designed, in other words, with the confidence of a railroad that expected to be in business for a very long time. Two contractors divided the work. Drake and Stratton Company took the eastern half. H.S. Kerbaugh pressed inward from the western bank. The laborers who shaped this structure included men of Italian heritage and local residents, hands from near and far, working through Pennsylvania winters and summers alike, laying course upon course of masonry across one of the country's great rivers. The sheer volume of stone involved was extraordinary. Each pier, each spandrel, each arch ring represented months of careful placement, the kind of work that cannot be hurried without consequence. By March of 1902, less than 2 years after the first stone was set, the bridge was complete. The Pennsylvania Railroad had built something that would outlast the railroad itself. For most of the 20th century, the Rockville Bridge carried 4 main line tracks, a testament to the volume of freight and passengers the PRR funneled across the Susquehanna. The main line of public works had once been Pennsylvania's proudest engineering achievement. The PRR had superseded it, and the Rockville Bridge stood as one of the most consequential nodes on that system, a choke point through which enormous tonnage moved day and night. When the railroad era shifted and the Pennsylvania Railroad merged in 1968 to form Penn Central, control of the bridge passed with it. When Penn Central faltered and entered what was then the largest corporate bankruptcy in American history, Conrail inherited its obligations. And when the freight map of the East was redrawn again in '99, Norfolk Southern took stewardship of a structure it had played no part in building, but would depend upon just the same. The 1980s brought modernization to the old PRR main line across Pennsylvania, and with it, a reduction from 4 tracks to 3. The bridge adapted, as it always had, but it was an incident from the late 1990s that would reshape operations in a way no planner had anticipated. During a period of high winds, an intermodal shipping container was blown from a freight train and fell into the Susquehanna below. The river does not give back what it takes, and Norfolk Southern took notice. The railroad ceased using the Y track to Enola at the bridge's western end, reducing the active mainline tracks to 2 and establishing buffer zones on either side of the remaining lanes. Open space designed to keep future containers from meeting the same fate as the first. It was a prudent measure, and yet the Susquehanna corridor is a place of genuine wind, and the bridge's exposed length across open water makes it vulnerable in ways that stone alone cannot solve. On December 27, 2010, in the aftermath of a major blizzard sweeping out of the region, high winds sent another container overboard into the river. The railroad had learned to manage the risk, but the wind had not agreed to cooperate. To this day, during periods of high winds, it is routine to park heavy trains on the bridge itself, using their mass as a windbreak, a solution that speaks to the resourcefulness of those who operate an irreplaceable crossing. There is one chapter in the bridge's operational history that revealed something unexpected about its own construction. When the track from the western approach was shortened to a new control point, designated simply as Mary, engineers discovered the reason was structural. The curve in the switch at the former location had been generating lateral forces powerful enough to blow out the side of a spandrel. That failure, occurring under the weight of a coal train on the downriver side, was destructive. But it was also illuminating. When the spandrel gave way, it answered a question that had quietly persisted among engineers and historians for decades. It had long been assumed by many that the interior of the bridge was filled with concrete. The failed spandrel proved otherwise. The core of the bridge was not solid concrete. And through failure rather than design, the bridge had offered its own testimony about what lay within its walls. In 1975, the Rockville Bridge was listed on the National Register of Historic Places. 4 years later, it was designated a National Historic Civil Engineering Landmark, recognition from the American Society of Civil Engineers, a body that does not dispense honors carelessly. The bridge earned both distinctions not through nostalgia, but through relevance. It continues to carry freight for Norfolk Southern and passengers aboard Amtrak's Pennsylvanian route, connecting Philadelphia and Pittsburgh along a corridor that has anchored Pennsylvania's economy since the Canal Age. It is not a preserved relic behind a fence. It is a working railroad bridge, doing in the 21st century precisely what it was built to do at the turn of the 20th. On July 7, 26, something remarkable crossed those 48 arches. Union Pacific Big Boy number 4014, the largest and heaviest steam locomotive still in operation anywhere in the world, made its way across the Susquehanna as part of a coast-to-coast heritage excursion, Union Pacific and Norfolk Southern units and passenger coaches trailing behind it. A machine born of one era of American railroading, crossing a bridge born of another, both still in motion, both still in service. It is the kind of moment that history occasionally offers without warning. A reminder that the past and present share the same rails more often than we think. Stone by stone, span by span, the Rockville Bridge was built to last. More than a century later, it has kept that promise without asking to be admired for it. If you found this history worth knowing, subscribe for more stories of human ambition in steel, stone, and concrete.